It's the second lesson of week 4. And as previously announced, I changed this a couple of weeks ago. This week we deal with display a list and navigation in apps. We already had one lesson with navigation from regular screen to another regular screen. We had paper, rock, scissors example. Done 2 ways. One using navigation system, and one is just brute force with flags. I explained it both because later Google provides example in the course I'm referring to where navigation is done with flags because in that case, system is complicated. It needs to adjust to different screen sizes. So they decided probably it's easier to do it without navigation system. So it was my motivation why I explained it these 2 ways. Definitely, when we use navigation system, we have far more features, which takes time to figure it out how to use them. So in some cases, maybe it's faster just to do some variable, which is page name of whatever. So it will have simple switch in the root window which part to show. If we use this approach, we will never have history button available easily, like go back button. Inside of the app, it's not difficult to make, but inside of referring to back button of Android itself, it's a tricky. In this case, if we want it, probably it's easiest way is to figure out how to use navigation system for that case. Also, in the next week, assignment 1 is due this Saturday, and it is last lesson before assignment is due. So if you have questions, please ask. Because sometimes it's hard to figure out. It's impossible. It's not impossible because nothing what I tell is top secret. It's on internet. It's developerandroid.com in various forums. But when you, or various tutorials, but when you do so, be careful about age of the code, because older code is not copy-pastable. You can still borrow some ideas, but it won't compile if you just combine older and newer code. And definitely in this course, we need to learn newer way of doing it, not how it was done with Android Studio 3 years ago. So for this reason, please be careful, because I'm using latest version of Android Studio, obviously because we installed this in class, like from developerandroid.com. But at the time when tutorial was written, it was slightly different code generated by Android Studio and compliant with slightly older libraries. So in the next lesson, I learned introduction to data persistence. So I will discuss 2 topics, but in details, we will go into relational databases. And just because we have only 1 lesson next week, because the first lesson is lost due to National Truth and Reconciliation Day, so coming lesson on Tuesday is cancelled by Sheridan, so I cannot really teach. If I come, to teach it, I'll probably run into trouble. So there is no lesson on Tuesday because it's National Truth and Reconciliation Day, but on Thursday, 1 week from today, we will have lesson, and I need to talk about room database. It means not room database. I will talk about relational database, and room, it is interface to relational database, specific one, SQLite. Android is using SQLite databases to store structural data for your application. So it is not centralized server. SQLite is not a server. It is just interface to edit and read and edit a file. So it is essentially a nice way to read and edit file using SQL statements. So, and it is quite a learning curve. For this reason, I will start it today. So today we will have example with lists, But data is not hard-coded like in the previous lesson. Data is coming from the database. So in the today example, we will have an app with simple database that is storing strings. And primary key is integer automatically generated. So it is only one table with two columns, ID and a string. Also, this example is simplified in terms of that it has only one page. It doesn't have navigation. But there are lots of things to learn. One thing to learn definitely, since it's using database, how to deal with databases. This is immediate issue, and there are other things. For example, reading and writing file, in this case it's a file, comes with delay, and our program needs to do it as concurrent task, so GUI is not frozen. And today we will learn how to create and run concurrent tasks. We will also learn how to use flows with databases. And we will learn concept of flow, because previously we learned concept of state flow, and we use it as just a state, as container. We didn't actually use any flow features from it. And today we will use flow from the database and connect it to state flow. So there are lots of new concepts. For this reason, I made a rather short example. But if we write a GUI code, there is no such thing as short code. So any good GUI code already large, because we need to specify multiple stuff. But it is still short because it's only one page. It has like only one list on it, one input, couple buttons. So it is an attempt to simplify introduction to complicated tasks. So in the today lesson, just because we lost coming lesson, it is in week 4. I will talk about use room with data persistence. So this link goes to the Google course I'm referring to. And there is a video introduction, and this guy talks about using flows, and this is the first time when we use flow. We use a state flow, but it is the first time when we use a flow. So it has, there is a topic how to test flows here, which is optional. I'm skipping now. There is another video using room Kotlin APIs. This is optional video, but watch it. And persist data with room, it is code lab. This example, it is quite extensive in terms of code. There are multiple pages in it, and it pretends to maintain inventory database. So it's a GUI example, and it's a database example. It's not practical in any sense, because nobody would maintain inventory database on a single device with no features to export the data in any way. So this program doesn't have any feature to export data in any sense. So it is practically useless, but it's a demo of creating database table, adding stuff to it, changing stuff inside of database table, listing it. So it is quite long. We will look into that at the next lesson. It really depends on the time, how much we have. So extent of how much it is covered will depend on limited by time. Assignment of 2, which is coming, so I need to post it at the next lesson, because Tuesday is lost, Thursday, it will be slightly more than a week before it's due, so it has to be posted on Thursday, 1 week from today. And Logically, since it's already middle point of the course, it has to be reasonably complicated but not overwhelming. So for this reason, I decided to have a program with, for you to do, a program with simple database, or just one table, a couple columns. At least you need to have 2 columns, Boolean and text. The story is shopping list. So it's not, it is not like inventory database with lots of editing features and so on. It is a shopping list, and it is also potentially practically useful because people may choose to store shopping list on device and when they go shopping, and you don't even need to export the data, you just look into the device. But in terms of inventory, you do need some kind of exporting data, whatever, right? So it is more practical than this example. It's also shorter because fewer features. So it will be shopping list assignment, like make an app that maintains shopping list. Definitely it should have a list feature, so you see list on the same screen. We're already somewhat familiar how to do list. Today we will have better example because coming from the database. In the next lesson we'll have more examples with list from database. So what is required? Definitely list, show list. Definitely add items to the list because it is essential for shopping list application. Add items to the list. Make it state change for list item, like done, not done, because you may not necessarily want to delete items that you already done. Maybe you want to check it first that it's done, and after this you delete it later. To verify original list and what is done. So it will be a text field, changeable status, done, not done, and a delete feature. If you want to make text editable, it's up to you. It's not requirement, but if you want, cool, do it. So in shopping list, requirements, make a list maintainable in terms of adding, deleting items, make status changeable, like checkbox or switch, done, not done. It means you already put it into shopping cart, so you put a check mark, done. And make it deletable items and clear entire list. It's only one list because this way you can deal with only one table. If you want to create multiple lists per shopping app, shopping list app, that will be additional features, but in this case you will have to have 2 tables with relations, right? A table for lists and table for items related to lists, all right? And technically it is, it's your choice, it's one-to-many or many-to-many because item could be on multiple lists, even the same item. For example, you create shopping list for a week and shopping list for Monday kind of shopping, and Saturday shopping, or Saturday shopping and Sunday shopping. This way, you will have overlapping lists, and the relationship will be many-to-many. And if you want to have not just consider simpler version, not overlapping lists, in this case will be one-to-many relationship, right? Speaking about relationship between items, definitely it is extra advanced topic and extra features to learn. It is not requirement on assignment, and it's not explained in this example inventory database. And currently, I don't plan to explain it. So how to code relations between tables in Android, but if you really want it and you don't want to learn extra, you can do it brute force. You can deal with tables separately and retrieve two items and link it after. So there is a way around without learning extras. Just deal with them as independent thing. You can still create foreign key, just don't treat it as a foreign key. Just create some kind of list, some kind of ID. Just don't specify it explicitly as a foreign key. Or just use SQL to retrieve it. It's another choice, but definitely there is a learning curve for it. So in your assignment, you will have only one table, so you don't worry about it. If you want to add additional tables, cool. You can do it as long as you don't link them explicitly. It is exactly the same approach. If you want to link them explicitly using API of Android, you learned it. Okay. So this is about assignment 2 that will be posted 1 week from today, so you anticipate what is coming. It is multiple screens, one database table, to-do list. So you have a list and details, and in the details you can check done, not done, or delete item or something like this. You can implement delete on the list, like put cross on it or little delete link. It's up to you. So this is quite extensive. We will look into that in terms of amount of code, because multiple screens, multiple options. We will look into that, but going through every line of the code, it's pretty much waste of time, so I won't go. I assume that if you care, you go through that. If you don't, nobody will able to force you anyway. Okay. Today's example is a shorter. It's only 1 page, and it's not editable. There is only a delete option, and it's only delete from the top option. It's not deleting any item. Okay. I will spend these 3 days that I have, like tomorrow, Saturday, and Sunday, to write example, not from scratch, but remember that math example with the quiz. That has a missing feature, like you cannot list problems because they're not stored anywhere, right? Because each time it just generates new problem. I will rewrite it because it has lots of potential in terms of explaining databases, in terms of storing list problems on cloud, so user can share data between different devices, like doing quiz on phone and on tablet, the same quiz start on phone, continue on tablet, or like something like that. So that example has far more features than this. This is dumb. That is not. That is potentially useful in case somebody wants to train on math. And also, it has additional feature to show settings, because that way you can select, I want only addition problems, only addition and multiplication problems, no division problems, whatever. So it's a settings for your quiz. And potentially difficulty of the generated quiz also in settings. Difficulty 1, difficulty 2, and so on. So that problem potentially has lots of space to grow, unlike this one. So I'm investing time into that. Right? Later in the course, we will have example, not to-do list. It is shopping list. Assignment is shopping list. Later we'll have example to-do list. Okay, it's kind of similar, but and code of course. That is for the cloud. Definitely, it's not copy-pastable because that example is storing data on the cloud. I will revoke that code to make it easier to follow, so it is linked more directly to what we know, because that code has huge learning curve. So this is a plan. So today, today information is coming from 2 points. Using room database for persistence. I'm not explaining the example today because it is quite a jump in terms of complexity. I'm explaining this using shorter example. And one feature, obvious feature of the course from Google, introductory course, that it it doesn't have explanation how to do dependency injection using Hilt. When we look into architecture guide from Google, they say explicitly it is recommended to use Hilt, dependency injection. But they don't have any course that is using Hilt except that course that remove it link, right? I already mentioned the course for cloud. It's because it has lots of missing features. It's hard to follow, so they decided probably remove link even to it. It exists. It's on web. It's in even the website, but it's hard to find. They remove it explicit link to it because it's kind of half broken. That is using Hilt. So if I use the example, I will have to explain Hilt. But that course is not explaining it. They just assume that somehow you magically learn it in between lessons. They don't have a lesson on it. They just jump from beginning to advanced thing. Okay? So for this reason, today's example contains two branches. One, it is done as in the introductory course from Google. And one branch is using Hilt dependency injection. So we can compare side by side what is the difference and learn correspondence. Speaking about this example for inventory database on a mobile device. Okay, dumb idea, but okay, it's a demo. It's not actual problem. It's not actual application. Okay, so they do not have Hilt because this course is not explaining Hilt dependency injection. They do it brute force dependency injection. So for this sake, I need to explain both so you can follow Google examples from the same course. I did rewrite this code before using Hilt and with additional features. And in this iteration of the course, I decided to give up on it. Because original idea was dumb. Who would want a relational inventory database on mobile device? Okay. So although I was rewriting this code before and it exists in multiple variants, I gave up on it. So I will stop rewriting it. And I will not use my own code in explaining it. I will just use their code. So for this reason, I will replace it with math examples that will be fresh and kind of more sensible. And later in the course, we will have to-do example, which is kind of similar, editable to-do list. So today's example is stack data exists in two variants, with Hilt dependency injection and without. Hilt dependency injection is potentially a complicated subject. Maybe this is why they wanted to skip it. But we will have just introduction to it. We will not cover all bells and whistles, similar to database use, because database code that is using database can be potentially quite complicated. So for this reason, we are sticking to introduction, and this course is, call it something principles, right? Mobile application principles. So we learn principles of how to deal with the stuff without lots of overwhelming details. So we have introduction into issues that we need to deal with, and some simple scenarios how to deal with them without trying to get pro in this area in the second year of the program, right? It's the second year of the program. It cannot be really overwhelming. So, but unfortunately, it is the last course in Android programming. So you have to have reasonable introduction in various topics. You will have a hybrid programming in terms hybrid programming course. You will have Flutter that allows you to create applications for different devices that have a similar code for different devices like iOS and Android. So that is a good idea to learn, but since it's this program is mobile programming, like mobile degree specialization, you need to have some introduction into native Android programming using primary native language, which is Kotlin. So this is unavoidable. But you will learn how to write Android applications different way, but it is the first and last course using Kotlin native programming. Okay. So this is why we have various introductions into various topics, because they will never be mentioned again. This way, at least. So today we will see dependency injection with Hilt, and it's not a tutorial. They had one tutorial with Hilt, and that is explicitly deprecated, so it says deprecated, don't use it. Okay. So this is theoretical introduction. As you see, these configuration files are for older Android Studio. When you create a project, it will generate build files this way. We can borrow ideas and by comparison write what is expected in current version of Android Studio, but it's out of date. Although this is current version number, so they keep old date format, but version numbers are current. So we can look up what kind of library to use with Hilt and apply this logic to configuration files of the project that we have. So it's not waste. Later they go into details of various scopes of the objects that we create. And I'm sticking to, it's a lot of information, definitely. I'm sticking to simplest singleton, okay? This makes objects global, and it is quite fine for its databases and access data from web. So I'm sticking to simplest case scenario with global objects. And example that we will use later for cloud, she is also explicitly using singleton. If you want to use bells, if you want to use additional features, definitely you need to invest time in learning it. So all objects that we create for dependency injection will be global, available through entire program. We can definitely optimize it if we really want to, if program is large, and this way you can make it, say, behave, I would say, quicker or fancier. Okay, it definitely requires extra learning. So I posted this link for you to just to look through quickly, get some ideas, but it's not about learning every line of what it says, because it's maybe overwhelming, especially in the introductory course. So it is just to get familiar what is it, and we will learn it by comparison. Two pieces of the code without Hilt and with Hilt, because it's a good idea to know both. Examples from the course that I'm referring to does not use Hilt, but we need to learn Hilt. So in order to stay current with the technology, so this is why it's a good idea to have some knowledge of both. So this is where we are. So let's dive into it. Stack data. So this program imitates stack database, not stack database, stack data structure. You know, you probably are taking data structures and algorithms course right now. And stack it is one of the simplest data structures, right? No, you don't? Yeah, we'll take it next semester, don't worry. Okay. Stack is a simple data structure with one input, one output, and you can input only from the top and take it out from the top. So this program is not using stack to imitate it because it is displaying content. If you use true stack data structure, you cannot see anything except what is on the top, but it is listing everything. So it imitates stack behavior, but it shows what is inside. So it's not using stack, it is using just listed. And this list is stored in the database. So technically it's database table. Okay. So let's clone it. And first thing, copy it, and let's clone it. So clone repository. Command V. And I will change this to in class. Like, because we already have version of it. I had it before, but I rewrote it, created project from scratch, and copy-pasted some older code into it. Why do I need it? Because Android Studio is changing, so it is using different libraries by default, and I wasn't sure that if I just use project from a year ago, code is copy-pastable into new project. So I wanted to be sure. So I created project from scratch, and I opened it project created a year ago, and I was copy-pasting code from project created a year ago to make sure it is still copy-pastable. So you can use copy-paste if you want to do assignments, because sometimes it's not obvious that it will work. So for this reason, it is slightly older code, but definitely it is copy-pastable. I verified by creating project from scratch and adding stuff. Clone a Trust project. By default, it goes to main, and main is not using hill dependency injection system. It is using factory to create view model. We already discussed it in words about complexity of creating view model, because potentially view model has dependency. And it's not immediately clear how to pass dependency to view model, because view model is generated on as needed basis. You call function view model, and view model function will create view model if it doesn't exist, but if it does exist, it will find one and give it to you. So it needs to know how to create it. And you don't call it explicitly, you just need to provide information how to create it. So for this reason, if view model contains dependencies, we need to not trivial dependencies, some that system cannot figure it out on its own. We need to create view model factory. In our previous example, if you look at carefully at the covered in the previous lesson, view model had one parameter, save state handle. We use that parameter to retrieve ID from the navigation system, item ID from the navigation system. So save state handle, it is a library object, and system knows how to create it. So it will give you it if you ask for it as a parameter automatically. But in many cases, we use dependency that cannot be created automatically by the system. For example, you retrieve data from web, and it is specific address on web, specific data. So there is no way to write Android code ahead of the time to know what you want to do with your data, right? So in this case, we definitely need to have a factory for repository dependency in order to deal with it. So this code, factory can be created automatically by HILT, but you still need to provide information how to create those objects. So HILT helps you to make shorter code, but there is definitely some learning curve. First, let's look into this project and run it and see what it's doing. Okay, so this is input or output. So I use text field to type stuff, and when I do so, for example, like okay, it is a string. So there is push button, and it goes on stack as the first item. These are not panels. I just use it frame around row. So it is just regular composable row with two items inside, number and text field. Why I didn't use, it's not panel, it's what's called panel? It's called panel, right? Oh, like, okay. I didn't use it because I wanted to show that in Android you can create frame around any object, including even row. So it is just frame around row. The same was about message. Stack is empty. So this part is implemented by list. Entire piece is scrollable, and this part will be scrollable if it is long enough. When there is something on the stack, you can pop it, or you can add one more item like B, push. This is stored in database, and it's stored as a table with two columns, ID and text field. This one is not ID. It is just count of what is retrieved from the table. And list is displayed top to bottom, but I decided to invert it backwards. So there is, so bottom of the stack is indeed at the bottom, not at the top. So there is a code that is changing order to opposite order. So whatever array is, it is retrieved as a list. There is a code that is changing order explicitly, so it is top to bottom. Just to make a demo, so second thing which is inserted is on the top, but not at the bottom, because this is how stack works. What is inserted is going on the top, and when it is removed, it is taken from the top. Just because I wanted to do stuff demo, I had to add code that is reversing the list that I retrieved from the database. Also, this one is not ID, it's a count of what is on the list. There is a big difference. Auto-incremented ID and count on the list. Because if we create a database with auto-incremented ID, we know it's possible from your database course. You can do that. If it is auto-incremented, it is last ID generated plus 1, which is not the case here. Because when we pop it, next ID could be 4, because we already popped IDs. But when we add things, it has to be 2, because it's count from the bottom. So this is not ID. It is just count. Also, one more trick for that. This is using view model and database, but this part, what you see on the screen, for example, you put C, is not stored in view model because it's stored in GUI, but eventually it goes to view model, and when you click push, it goes to view model and database. It is done for simplicity. It is just state variable in the GUI. It is possible to put it into view model, definitely, but I figured it out that code will be a little shorter if this part is in GUI. And I didn't force myself to put it into view model with longer code, because if it is simpler, let's stick to simpler. This is not a cult religion. It is just a recommendation from the Google, and they teach various things because sometimes different things are simpler than other things. So although there is a view model, but what is on the screen in this box is not inside the view model. It is just part of, it is just state variable in the GUI, because it was simpler. Why it was simpler? Because when I pop, it needs to update it here. This part, it doesn't need to, but this is how I made it. when pop, this number you see goes here. Not number, letter is going here. So this pop feature, when this is updated, it's easier to do it if it is in GUI, not in view model. Slightly easier. So for this reason, this is just not a bug, it's a feature. Right. How to see database? Definitely when we write program, we need to debug it. And one way is to debug it with tests, creating test cases specifically for database. This doesn't have test cases for database at this moment. So, but we want to see that it behaves right. We don't see database on the screen itself, so we don't see database table at this moment. But Android Studio currently provides feature so you can see database tables. So it really helps you to debug what is going on, because we cannot debug if we don't see what we currently have in database. So how to see it? There is some menu item, call it app inspection. App inspection, it's here. Okay, click app inspection, and it needs to run when you do so. And you see items, item database, it is database what I have. It contains table items, and this is some kind of helper table. I didn't create it myself, it is created automatically by ROM. What is ROM? ROM is object-oriented access to SQL, specific SQL, database SQLite. So we will use objects to store and retrieve rows of tables. R, it probably stands for relational database. Right? M, mapping. Or O, maybe object-oriented. Okay, so ROM. So it's most likely it's an acronym, relational object-oriented mapping. So this is quite common concept when we map, or programmers map, objects to rows of tables. And it happens in multiple languages, in C#, Java, and in particular Kotlin and Android. So in particular here, Kotlin and Android. How to see it? You double-click it, and it will show content. You see, ID is now 12, because it was out-incremented each time when I was inserting objects, inserting items to the screen. So not to the screen, to the app. So let's put something else like that. Okay, push, and you see, this is not automatically updated. In order to see it, you either refresh table here with button, or click live update. In this case, it will be automatically updated. Okay. So let's do this, refresh. Okay. Now you see that it's technically bottom of the table, right? This is just count. And ID is 13, but this is just 2 because when I retrieved it, I counted it. One cool feature, and this is really cool feature, and we need to see it. Okay, so let's do it. This is magic. It is magic of using flows. So I'm clicking on what is inserted, for example, on A, and I type something else. Let's try. So I'm changing A, to, for example, Alex. So it is this field, right? And I press enter. Ta-dam. Have you seen it? So what do I have? My app reflects content of the database. I didn't have any refresh button on the screen, right? It automatically updates what is on the screen directly from the database. How it was achieved? API of this database is using Flow. And database is, there is some function deep inside of database API that is triggered when the table is updated, like this. And that function is inserting new data into the flow each time when database is updated. Right? And this flow is connected via state flow to the screen in view model. So screen is showing current content of the database each time. So there is no refresh feature, retrieve me, please, every second. So it is update of the screen is triggered by the update of the database. Let's make it clear. There is no explicit refresh of the screen because we retrieve data as the flow. And flow states linked to the database. And data, every update of the database table is inserting new data into the flow. So this is how this magic works. Okay.
We can't edit it, it's only showing your results are really on.
What?
Like the way you edit the value?
It shows immediately here. See, when I tap it. He did Z to something like Sheridan, right? Okay. And then when I press enter in the database, you see, Sheridan goes next to number 1.
But I can't edit it.
You click at this live update. Remove this check mark. After this, you can.
Oh, okay.
Editing works only if you uncheck it. I don't know why. It's just. So that was a demo of using flow. It makes program logic somewhat simpler because we don't need to have explicit refresh. But we need to link database to the screen. So it is extra learning curve, but it makes it simpler. Right? So let's dive into code. Previously, we had to create lots of, when Access wasn't object-oriented, we had to do queries and create objects ourselves in our code. So API was retrieve data from a row and create object based on items that you retrieve, like column values from query that you got. So that was quite complicated. Room is about, it's about like 7, 8 years old. It is object-oriented access to SQLite. So we define what we want, but we need to know grammar how to define what we want. And system will generate code that we don't even see, but it will provide code for us. So we will call APIs of that code. This is quite common in Android. The same idea is used to retrieve data from web. We describe what we want, and system will generate code for us, and we will call that API. But we need to describe it right way, obviously. So first, in order to define this data storage, I need to define this in terms of objects. Objects that you store as rows of database table, they are called entities. This word is used in other object-oriented access to relational databases. Entities is quite common across database technology. So entity is essentially object stored as a row in a database table. So I created data layer, and I created local item. It is what is stored. And I define it as entity, and this is table name. How to store. If I don't define table name, it will use class name to define table name. So I call it local item because it's stored locally on the local database. When we define entities, there are two things are absolutely required: keyword entity on top and primary key. Because system is not able to figure out what is unique in your case, and you need to specify which field is unique to be used as primary key. So what is primary key? From the SQL course, it's some item which is unique per row, so you can retrieve by it, and system can organize it. Auto-generate true, it means it will be incremented starting from 0 and +1 each time. When you delete items, it will not renumber them because it will be too complicated for the system to maintain. So it will just add one more. This is why I have 12 and 13 when I have only 2 items here for ID. This will not work right away. So in order to use room, we have to include room database, room libraries. So in order to use local database, we need to add stuff into configuration files of the project. So these will not be available by default. So let's see, before we go into code, let's see what libraries we need. Let's look into tom.ml file. As you saw, room is using annotations. It is add primary key, it's called annotation, or add entity. So it is annotation. Okay? In order to process annotation, there are 2 approaches, KSP and capt. KSP, I think it's called Kotlin symbol processors or something like that. It is plugin. It is designed as a replacement of capt. I think capt is called Kotlin annotation processor something. So KSP is designed as a replacement of capt. So in some code, you may see capt, not KSP, because it's just 3 years old, something like that. Unfortunately, there is no way to edit through GUI. You really have to copy-paste this part. You go into documentation, or if it shows older format, you match what you need with older format and figure out how it should be called, and you could make this line yourself. Android doesn't have any GUI feature to edit. So there is no way to add, go through that menu. Remember how we edit libraries. Project structure to add library. No, you have to copy-paste this one. Okay. It is referring to version number, so you have to put it here. How to know this one? This has to match Kotlin version, and this is automatic. You don't know this one. And there is no easy way to figure out this in Android Studio. The only way to figure it out is to do Google and search KSP repository, and it will find some repository website where this library is stored. You see lookup number. Okay? And this is not automated in any sense. So you look up number for Kotlin. It exactly must match, otherwise it will not work. And this number you Google KSP repository, it will be some website where it is getting this stuff, and you look up this number, no other way. It's not automated. So currently, we need to have a KSP. Maybe there are other ways, but this is how I matched this to the course I'm referring to. Okay. We need to have a KSP, and we need to figure out this number. Otherwise, we cannot guess, either from documentation or directly from the website where this library is coming from. When you do assignment, copy-paste from this. It's easy. Okay. So you don't have to browse web for this number. Next, in order to use databases, we need to currently include two additional things, this and this. These two parts can be added, these two can be added through project structure, but you need to know what to add. So we are looking for room runtime and room compiler, 3, and room KTX. So we need these 3. Room runtime, room compiler, room KTX. If we go to project structure dialog, it will be a huge list of other room libraries for different features. But for this particular simple projects, we need these 3. If we need to do automatic testing on the database, there are extras to include. This project doesn't have it. So when you do assignment, you either copy-paste it from this project or add these 3 from project structure dialog. But you cannot add this from project structure dialog. If you try, it will add it into wrong place. It will be here in wrong given version number. It's totally broken. Okay. This is about TomML file. This is not end of the story. Next, you go to global file, build Gradle, and add KSP. Remember that this is alias name. So if it is called in alias, I call it as DevTools minus KSP, it has to match that. So I call it this in TomML as DevTools KSP. So in global Gradle file, it is DevTools KSP. If it's not matching, it's not compiling. It's not automatic, you have to type it. Also, in this file, similar thing, DevTools KSP here, not automatic, you have to type it. Okay. Next, going here in dependencies. This is inserted by the dialog when you add a room runtime. That dialog adds this line, so this is automatic. Next, this is also automatic. Libs Android room KTX. This will automatically say implementation, but you need to change it manually to KSP. So this has to be edited. It doesn't do it right automatically. So you need to change this part manually, and you need to synchronize it by clicking elephant. Unfortunately, as you see, some of it has to be copy-pasted and edited manually. By far, the shortest path is to copy-paste it from my project. Okay, but if you want to recover this next year, definitely you cannot copy-paste it from my project because next year it will be different. So you will have to look up documentation, check project structure dialog, check version numbers. So, but for assignment 2, it's probably easier just to copy-paste this stuff from here, but definitely next year you need to look up what is current situation. Okay, because next year maybe just different library call it differently or something like that. All right. So in order to use room, we need to include 3 dependencies. We need to include also plugin KSP. There is also room plugin. This code is not using it, and I'm not sure what it's for. There is also a room plugin, maybe for some other features. Okay. I'm sticking to analogy with the Google code that I'm referring to. So I converted what they had into newer version of Android Studio format using new library version numbers. Right? So this is what was added. After this, you can use ROM. Okay. Since it's in my code and it's video recorded, when you do assignment, you can recover this thing. And definitely when we did these files, TomML, build Gradle, we have to synchronize it with Elephant. So let's continue. We create entities. If you have more than one table, you could have more than one entity. And if we have relationship between tables, we have to add more stuff. Okay? The easiest way to deal with relationship just to create it as not related, but with ID field, which is assumed relation. So you deal with separately and link these objects afterwards, something like that. If you want to use Room API to retrieve them together, there is some learning with it. So assignment doesn't have more than one table, so nothing to worry about it. Okay. Next, we define item DAO, or DAO. DAO stands for Data Access Object. It is not per table. What people typically do it per table, only because of separation of concerns. So this DAO is for this table, for example. If you have fancy queries that relates to several tables, definitely you need to do maybe some combination of it. Technically, you can have one DAO for several tables. It's not fixed. So DAO stands for Data Access Object. It's not Raw Access Object. So potentially, you can add whatever you want. So what DAO includes? Description of what you want from the generated code. So it is not the code. It is description of what you expect in the generated code. So let's see what kind of descriptions we can have. For example, insert. This is item. System is smart enough to know how to insert data from the given object into generated table. So we don't write this code by updating database table. We just say, we need a code to insert this object into the table associated with this object. And system will generate the code. Okay. Similarly, there is also delete. But in order to delete, you need to provide object. I'm not using this delete like this because it's less convenient. You need to have an object to delete. There is also delete. If you want to delete by ID, you need to create a query. And I do have it somewhere. Yes, delete item by ID. See? And query is just regular delete SQL with marker to insert this variable. See? So this is column and variable name. It's a place where this is supposed to be inserted. This code will be generated based on the description, this kind of SQL with variable inserted. See? There is also add delete But in this case, you need to provide object to delete. Okay. So what kind of descriptions I have? Query, select a value. It is regular SQL. It is column name that I want to select. Right? From table items, order by ID descending order. Descending, it means largest item first, right? So flow, a flow, why it is order by ID, so largest first. So it is reversed here, right? Am I right? It appears like it's reversed here because it is descending order. Order by ID in descending order. So last one will be first. And what is returned? Flow and a list of, it has to match SQL. Since this is a string, value is a string, and this is a string. Please notice that there are two kinds of functions in this case. Returning flow and function that technically is not returning anything, but could. They suspend. Okay. So in DAO, we have two kinds of functions. They either return flow or functions that are suspend. Let's talk about it. Are we already familiar with flow, right? Somewhat familiar. When function is returning flow, it creates link to updates of the database table. So when updates happens, it will insert new data based on the query into the flow. Okay. So there is a query. When it will execute query again and insert new data. So flow is linked to query. It could be the same data because update of the database table will trigger execution on query, and query will be executed, and it will reinsert data. It could be the same. So potentially, it could be the same data in the flow because database table was updated, so it doesn't know if it will be the same. It just executed query, created new item in the flow. There is a possibility to optimize it, but we are not looking into that at this moment. So by default, it will re-execute query on the table on every update of the table and insert data into the flow. What is flow in this case? Are we familiar with state flow? And we use state as a container. Flow does not have a container in it. So insertion in the flow is conditional of something is picking it. So it will not execute any code unless some code previously linked to it, because flow does not have a container. It's impossible for the flow to insert anything to it, because there is no place to keep it. So this is why flow is called cold. It's not doing anything, it's lazy. It's doing work only when result of the work is needed by something. Okay? So it is doing the work only when something is watching for the work. So it's a lazy worker, okay? Or optimized worker. It does not do useless work. Okay? So flow does not have a container, so it is not able to execute data and insert it unless container is attached on the opposite side and something is grabbing the data into the container. So flow is optimized this way. Okay. So the reason, and it is the reason why it returns flow immediately, because first it is empty. Later, it will execute query if something is attached to the flow. Okay? So flow object is not doing anything by default, and this is why returning empty flow is immediate. You don't even need to execute SQL. SQL will be executed when something is asked for data. Okay? There is no delay in returning flow because it's empty. It's not difficult. But sometimes there is a delay. For example, get item by ID, and it is returning string. Right? It needs to give a string, and string is already data. It is not a flow of data coming later, right? It's already data. It means it has to be done. You cannot give empty channel and say, okay, later I will put something there. Right? This has to be data, and so this is delay. So functions that can have a delay, they are marked with suspend. So it's an instruction to the system that there is a delay in it. Okay. There is some under the hood logic, but in terms of plain level of understanding, every function that has a potential delay, like waiting for the data, like give me item by ID, so ID 14, what is string, it needs to execute query before giving the string. So there is a delay. It needs to read the file. Okay? And this is suspend. Also, flow is updated automatically, and it is data in the flow is pushed automatically when something is asking, right? Or when something is asking and table is updated. Okay? So flow is not one-time operation. It's refresh, automatic refresh on every update of the table. Suspend is one-time operation. When you ask it for get item by ID, it will give you string. It will not ask again unless you call this function again. Okay? So there is a clear difference, should be clear, that suspend is one-time operation. You call this function, and it will execute query, and it will give you result, and it will not re-execute this unless you call this function second time. But flow is multiple queries executed each time when database table is updated. Questions? So what about transaction? A transaction is a combination of what we have. And it is done in one step under the hood. So it will create, it is actual code that is calling something from here. So it is a combination of other things, other calls. So what do I have here? Top to the bottom, get a list of strings. Next, in order to remove something from the top, I need to know what is the last count, right? So I'm looking for max of IDs. So it will, biggest ID, it is what is inserted last. Correct? It is suspended and it is here. Next, in order to delete what is the last, I need to have a delete by ID and I call it for the last ID. This is how my transaction is combined, delete last one. Next, get item by ID. So it's a string, it's used somewhere. Okay. So get item by ID, and it is a string. I believe it's used here. Ah, this is where it's used. This here. After it is deleted, I need to display it here. So this part is used here. Because delete by ID itself does not give you what you deleted. It is just gone from the table. In order to display it here, I need to get the last one for the sake of displaying and delete the last one. So it's a combination. Okay? Because deleting itself does not give me data, what I deleted. Okay, so in the delete last item, it is returning string which is deleted. So first, I get last ID, max ID. Second, I remove it. What is removed is returned by this, so I can display it here. Okay, and after this, I delete item by ID, and it is maximal ID, so it's done. Okay. And insert, obviously, new item. When you push item ID, I set ID to 0 by default, and it will insert out incremented one. Okay. And when we define ID, we can define it as nullable. If it is nullable, you can assign null, and it will change it to not nullable. Or you can do int, not nullable, you just assign 0, and it will create new one. Let's look. This is val. It means it will not update the project that you pushed, because val is not updatable. Okay. But when you retrieve our object, it will have ID because it will create objects when you retrieve them. So it is not updating the object that you push in terms of ID. It's not editable. But when you retrieve stuff, it will be already with correct ID. So it's about DAOs. We can have more than one entity, and we can combine logically this operation in DAOs. Could be one, could be more. It really depends on your choice. So DAO, it is data access object. It's not row access, not table access object, not row access. It's technically it could be unrelated. DAO is marked on top, and it is interface. System will implement it automatically in the code. Now we have a chicken and egg problem. We need to call methods of something that generated automatically. Right? So next step is to look at database. So item database. Database is an object to access database. It's marked with database on top and parameters. So it's here in annotation, entities. You see, this is array. So if we have more than one entity in database, this array will contain mentioning of those classes separated by commas. So it will be, say, for example, shopping list item. And if you have a shopping list table, it will be shopping list, comma separated. Okay. So it is mentioning classes, comma separated, related to the database. Common mistake. Sometimes students realize that they need two database tables, and they stick it into two completely different databases. It doesn't make sense. You just put it here, comma separated. Okay? Database is abstract class. It is abstract class because system will generate code for it. Okay. So it is abstract class. Next, let's go through this line. Version. This is not version of your program. It's a version of your database. Why do we need it? Imagine that you release different versions of your program, but, for example, 2 versions still use the same database files. You don't need to change anything about database files because it is the same kind of database. So this is version of the database of your app. So when you update app, this number will trigger code to reorganize tables. So you'll have to write the code. So if new version of your app is using different database, you will have to write code to convert existing database into a new one. And this is how to keep trace of it. So potentially, there are extra things to work if you keep releasing apps and periodically you change to newer format of the data that you store. And that will trigger update. You need to write code to be triggered by this number. Right? Export schema. This is for database. This is for debugging purpose. It will create JSON files that describe the database. I never used it. It was always false for me. I don't know why it's used and by anybody. So it is a description of the database in JSON files. And I set it to false because I don't care about it. In all examples that I saw, it's always false. Okay. Now, it is abstract. Why? Because it has reference to interface. So this is interface. Item DAO is interface. And we don't have a code for it. So system will have to create a class that is implementing this interface and add it to it. So system will create implementation of this abstract class in terms of exact class, where this interface is implemented. So if we have more than one entity, they will be separated by comma in this array. If we have more than one DAO, you just have abstract one DAO, another abstract, another DAO. So your database can have, database class can have as many DAOs as you like. You just put them as separate variables. Okay. Sometimes in the code, the DAO is not property. In this case, I define it as a property. You can define it as a function returning DAO. So if we use like parentheses here, so it will be function returning DAO. Both ways it is understood. So sometimes you will see that as a function returning DAO. And of course, if it is defined as a function returning DAO, you call it as a function. In this case, it is dot without parentheses. All right? So it's abstract class implemented by the system. How on earth it works? This is how it works. We have companion object. So let's look inside of companion object. What is companion object? It's an object associated with every instance created from the class. Remember that abstract class doesn't have implementation. So it is implemented by the system. So how's this magic? How does it work? When we have a function inside of companion object, we don't need object itself to exist because we can call this function using name of the class. So this one, get database. So in order to call get database that is returning database, we need to use name of the class, item database dot get database. So we can call this function without class actually existing. Implementation existing. Next, What is this? You cannot return interface or abstract class. This is already implementation. So this function is returning implementation of abstract class. So this is how it is created. So again, in order to call method from companion object, class, so implementation doesn't have to exist. Okay, object doesn't have to exist because we use name of the class. So we use name of the class to call this get database. And what it returns, it's not abstract class. It has to be implementation of abstract class. You cannot return abstract object, right? It has to be exact object, yes?
So the companion object is similar to a static?
Yes, it's similar to static. It's not exact under the hood, but behavior is the same. So this is return it already implementation. Where it is done? It's done by build. So let's see. First of all, what is this part? Instance. It's a private instance inside of companion object. It's a data field, right? Data field inside of abstract, inside of companion object. It is nullable, and it is null by default. What it is? Implementation of this abstract class. So we store implementation of that in companion object. How it creates it? First, get database, return instance. Okay. What happens this one? What is question mark column? It means use this part if it's not null, but otherwise calculate this and use what is returned by that part. Okay? So when it is not null, this function returns you implementation. Okay? But it starts as a null. So first time it needs to execute this part. First time. After this, it becomes not null because it is assigned here. See? So, okay. What is synchronized? Synchronized, it's a block that guaranteed to be executed by one thread. So synchronized block is not executed in parallel. So it is trick. So in order to know that it's not executed in parallel, it should be some kind of flag. That when execution thread is entering it, it flips flag, busy. It's like a kind of lock, right? Or like a bathroom lock on airplane, right? You turn the handle, it shows occupied, right? So this is synchronized block must have some kind of flag to tell other threads that this is busy, do not enter it. It's like toilet on airplane, busy, do not enter it. So it should be some place to store this flag. And it is stored here. Log this. This is referring not to time database. It is referring to closest object. And the closest object to this is companion object. So this is referring to companion object. In Kotlin, the same as Java, every object contains special flag used for synchronizations of threads. And it's called log flag. So synchronized this is referring to the object used for this log flag. Okay. So it is block is specific for a flag. So this way you protect area so it's not executed in parallel. Why it's not should not be executed in parallel? Because you are about to create database on the hard drive, so you're reading writing files. You should not corrupt them. You should not create two versions of the same database. So the code that is creating database on the hard drive should not be executed in parallel. So this is why it is protected with synchronized block. Do not run it in parallel. And flag is stored in companion object, log flag. It is flipped when code is entering, one thread is entering this code. And it flipped back when this thread is leaving. Okay. So this is the meaning of synchronized block. Do not execute this in parallel, essentially. And how does it know? Thread which enters it flips the flag. All right. So first time you are here. And what does it do? Room database builder context is given to get database. Context is a base class for multiple classes in Android system that relates to application itself. For example, activity, service, or application class. There is a special class called application class. They all have context as a base class of those objects. In particular here, it is base class of application class. Why not activity? Because activities are created and destroyed. You want to have something more permanent than activity. So in this case, it's application class. Context of application class. What is context? It's an object that describes application in general. In this case, it needs to know where to create files for the database. So it contains information where to write database. So it is picked from the context. What is this? In order to create an object based on the description, you need to have a description. And it is referring to class. What is class? Class is a description of the class. Every object contains class part. It's a description of the class itself. It's used in reflection. So class, column class, it's a Java object. You know that under the hood, Kotlin is converted to Java bytecode. It is description of what we have here, item database. So it is creating implementation based on the description right here and based on stuff inside of DAO. Okay? So magic is happening here. Database builder is creating implementation of this abstract class based on the given description inside of DAO, inside of item entity. And description is given at this moment. Class is description of it. Okay. What is this part? It's the name of the database that you saw, but under the hood you see item database. But under the hood, it's the name of the files, like beginning of the name of the files on the hard drive. Because SQL database is stored as some set of files on the hard drive of the device. It's not a server. It is just files edited by the libraries. So where to see them? If we click on this ... we will see device. Okay. Okay, what is that? See. Am I right? 1 second. Build variant structure, find bookmark. What is this? Build. I just saw it, 1 moment. Structure, services, profile, links, build coverage. How comes that I don't see it? Okay, let's look for it. I'm looking something like not net device manager, something like Explorer, device explorer. Let's try to do tools device explorer or something like that. Find, build, to do, task and context. Let's try code refactor view. Let's try this. Tool windows, device explorer. So it is in view, tool windows, device explorer. Right? Click on this. It will open, it has to run. It will open somewhere. Where did it show? Okay, let's do it again. View, tool windows, device explorer. Oh, no.
The bottom one.
Does it show you? Oh, here it is. Here it is. It shows that here now. You click on it and it shows here. So if it doesn't show, you click on this one. What do you see? You will see hard drive of the device, of emulator. You scroll it, you find data, and it's like a data folder. In the data, there is another folder, call it data. Scroll it, here it is. And after this, you see names of the packages of these stuff, applications installed on your emulator. You see Dice Cube, right? Mass Trainer. And this is why I'm asking you in assignment, use your login name to make this location unique. So database from one user will be in different folder from the database of one student will be in different folder from database of another student. So they will not overwrite each other, they will not cause crashes. Okay? So this is a key point. So I'm looking for folder of stack data. Here it is, stack data. You see database folder and files of the database, item database. So this is a key point. This is why I'm asking you to use your login name as a part of the package, because it's a location of your update on the hard drive. So stuff written by app of one student does not override stuff written by another student. So there is no crash about databases because of conflict between apps. You can still run into conflicts of your app with previous database on the hard drive. This happens a lot to students and to me as well when I make mistake. So you don't delete this directly. It is done easier. If you expect to change your database, for example, you rename a table, or you added extra column to table, or remove it column to the table, and you run your app, it will cause crash because there is conflict between what is written as the files and what your app expects. Okay? How to deal with it? Dumb way is to change this to 2, and it will delete previous one. But easiest way is to just to go to device itself and run uninstall of the app. How you uninstall it on Android device? You grab icon of the app and move it to trash can. This way it will wipe off your database files, and so you will not run into conflict with your previous database files. So this is absolutely the most common issue with dealing with databases. You create tables, you put some data into it when you run it. After this, you decided, okay, I want to have extra column. But existing database has table without such column. So when you run it, it will run into conflict and it will crash your app. So in order to avoid it, just stop it, find it in applications. So, okay, how to, okay, what's that? Trust app, okay. Find it where it is, what it is. Or you have to look at it carefully. Zoom it if necessary. Find your app, stack them or something. Stack data, right? Stack data, grab it, and move it to trash can, uninstall. Do you want to uninstall? Yeah. This will wipe off database files. And this is absolutely critically necessary in your assignment because sometimes we want to have extra table or rename column, and it will start crashing because of the conflict of what is on hard drive and what your app, newer version of the app expects. Right. So this is hard location, right? What is this one? And this is default behavior when this is changing. And this is definitely not necessarily what you want when you release your app, because it says, if it is new version, just swipe off previous tables, create new one. So if you keep it like this and you release it with new version number, your users will lose all data from previous version of your app. So you need to add extra code to do conversion of these database tables. And I'm dropping that one because by the time when you need it, something will change, right? Also, it's advanced topic. So default is what it says here. This one means if this number is different, just delete database tables created again. So it means user will lose the data. We need to add extra code that is handling different versions. So, and it's definitely your app specific, how you need to convert. You need to retrieve data from one table, create new one, and put it there, something like that. So this is the meaning of fallback to destructive migration. What to do when this number is changing? Destructive means kill it, essentially. Database. A build will create the object based on this description given here. And also, remember that in the beginning of the course, I described scope functions. Like let, also, what's this, with, right? Also, it's a scope function that defines it to the object it is called. Build is returning database object. Right? So it's already implemented database object that will be assigned to this one. You see? Instance. See, instance will be assigned here. So second time when it is executed, it will return not null one. So it's a trick to create only one. Because second time it will return existing one. Because this will be not null, it will not call synchronized block. What is volatile? Volatile, it is related to the fact that under the hood it is Java. And it means do not create copies of it for optimization. Because we are checking null, not null, so it is checked from one place. So there's no multiple copies. So, and it's also related to the fact that this library is in Java. So we're talking to Java library at this moment. Room, it is backward compatible with Java, so it's done in Java, and we call it from Kotlin. All right? So this is, when we use hill dependency injection, this code can be done simpler if we want. Or we just stick to it by copy-pasting, because it is just generic thing that you just copy-paste and rename stuff. We don't have to remember it. We can copy-paste. Questions about this part? So now let's see what else. Okay? So in order to retrieve data, we call methods of DAO in the implementation of the class. Somehow, we need to link this database to repositories, and repositories link it to GUI. Okay. Next step is to look from the opposite side. So now I want to look at this from GUI point of view to see what actually I have. Okay? So in UI, I have package for the screen, and it is called stack. In the stack, I have view model. A view model is using stateflow. So we need to attach stateflow to the flow because we need to store data somewhere. Flow does not have any storage inside of it. Flow works only when something is pulling the data or asking for it. It's not even doing database queries unless something is asking for the data. Who is asking for the data? Stateflow. Stateflow is active or hot flow because it's asking for the data. How does it work? There is a here started, sharing started, while subscribed, and this part tells grab the data when one second. Remember that in order to convert state flow into state, we call it collect as state function. Remember, it was function collect as state, right? Inside of GUI. With any state flow, we had a function to convert state flow to state. So in this particular case, you see, collect as state. So this is pulling the flow into state object. So collect as state, technically it is pulling the flow. But it's not always pulling the flow. Because activity can be discarded during rotation of the screen. So it's not always pulling the data with collect as state into state container. Because it's not always existing. GUI doesn't always exist. So what does this mean? If collect as state is not pulling it, continue pulling data for this amount of time, 5 seconds. Okay, so state flow will stay active for this time limit, even if collect as state is not pulling the data. So this way you have fresh data if activity is recreated. So this is a trick. Okay. Flow will keep flowing only when something is collecting the data or pulling it. Okay. You have collect as state inside of a GUI to pull the data into state container. If it's not pulling, and it's not necessary pulling because activity GUI is discarded during rotation of the screen. State flow will keep pulling the data for this time out for 5 seconds. To have the fresh data in view model in case activity is recreated, so here it is, new fresh data for you. So this is the meaning of while subscribed for timeout for 5 seconds. So what does this function do? State in. State in is converting flow into state flow. So it's taking flow and making state flow. Right? So what is this one? Map. map is doing data transformation inside of the flow. So it's a method of the flow to convert data inside that is going through. So it is current item from the flow, or parameter of this lambda function, default parameter. So this is item from the flow. And I'm calling constructor UI state because I need state flow that contains stack UI state in the end. Remember that original flow contained only strings. But now, in the end, I have a flow of UI states. So there are lots of data transformations in the flow chain etap. So when UI is receiving it, it's not exact data from the database. It is data from the database converted by flow transformations in it. And this part is doing data transformation on the flow returned by data repository. So this is data repository giving us flow, and this part is converting items in the flow into stack UI state. So we have a conversion of the data in the flow. And this is just calling constructor of stack UI state and what is items. So let's see, stack UI state and items, it's a list of stack item. Right? So stack item, it's not a string. In my case, you see it's different. And you saw that when you run it, okay, it is essentially what is here. You put it. No, it's not. Okay, here it is. Stack item for me, I join it count with letter or whatever type of word, okay, with a string. So stack item, it is here, define it in my domain as just count and a string. So my database is giving me flow of strings, but something is changing this to flow of stack items, right? Who is doing it? Repository. So there are several data transformations in the flow. Last data transformation is done here in the view model. When I call stack items, when I pick stack items from the flow and give it to constructor. And now I have UI state in the flow. It is last data transformation. Previously, I got flow of stack items given by the repository. Okay. And repository is converting flow of strings into flow of stack items. So there is a dynamic transformations in reactive sense. Something is pulled from one hand, okay, is triggered to insertion and into flow, and we have flow transformations of the data. Now something interesting, scope. So this function, state in, is converting flow into state, right? What is view model scope? It is done as in independent task. So these flow transformations, pulling, all this is done in the background. So it's done in separate thread from GUI. So GUI is busy doing own things. But this is done as concurrent task. So it's a scope of that concurrent task. And this scope is view model scope. It means that task will run only when view model exists. And we definitely need it only when the view model exists. When it doesn't exist, why would we run it? Because view model provides the data to the screen. This is where, this is the scope of the task. So if view model somehow discarded, you go to another screen. And this is not necessary. It will stop pulling the data. So it's optimization. So this is the scope of background task of pulling and processing the data. And it is view model scope. So when view model is destroyed, all those magic stops flowing, right? All right? So this is how you get data on the screen. I didn't explain what is in repository yet. We will look into repository. But before we go to the repository, let's see what else we have. Timeout, okay, it is just a constant. A repository is given as a parameter to view model. So this is where it gets it. So we can call method get stack items on that. This is flow, and we have flow transformation. What is this? Pop. Pop, it is operation that will cause something in the database, right? And like deletion, retrieving, right? Okay. So what is launch? View model scope. View model scope, we already discussed it. It's the scope of the task that we start in as background. So it's not, it's running independent of the GUI, so it's not keeping GUI busy. Right? It's a data providing task. And the task will be canceled if view model disappears. Like we go to another screen, for example. So it's a view model scope. Launch. We are launching task for the view model scope, and we is executing repository pop. A repository pop is suspend function. It is defined as a suspend because it is linked to another suspend function in the database. Suspend functions can be executed only in coroutine scope. So this is called coroutine scope, some background task scope. View model scope, it is special case of coroutine scope. So suspend functions are special functions, potentially long in terms of execute. In keywords suspend tells the compiler, check it. You have to execute it specifically in coroutine scope. In this case, view model scope, special case. So what did we learn? Suspend functions must be executed in coroutine scope here. So repository pop, similarly push. View model scope launch, we are launching background task in view model scope. Okay? So this is how to launch concurrent task, independent from UI. Now, there is also magic inside of repository. So let's open repository. A repository, it is in a data repository. This is just an interface, and you see get stack items gives me flow or list of stack items. So repository needs, in this case, repository is converting strings to stack items, string and count essentially. So there is a data transformation in it. And you see push and pop, they suspend functions, so they have to be called in view model scope or in some coroutine scope. View model scope is a special case of it. Next, implementation of it, I call it local repository. So let's look first at suspend functions first with context. When we execute background task, so there are special framework to execute it, and it is optimized depending on what you need to do. This dispatcher of the task I/O is optimized for inputs outputs. Because when we use inputs outputs, most of the time we just wait till something else is doing the work. So it is optimized for inputs, outputs. There are other dispatchers, but this is, I'm doing input, output, so I'm using the one which is optimized to dispatch the task, coroutine task, specifically into the chain of dealing with inputs, outputs. Tasks dealing with inputs, outputs. Okay. So this is the mini. Change the context of what is launched into input, outputs, so it is done specific, optimal for inputs and outputs. And I'm calling DAO insert. And DAO already has implementation of it, of insert. The same as here. This is more interesting. First of all, it is flow only for list of stack items, so I need to do data transformation in the flow, because the original flow gives us flow of strings. So item DAO get all items flow, this item DAO get all items flow. Item DAO get all items flow give us flow of list of strings. So that flow will contain lists. Not just one list moving through, but one list going, second list going, third list going. So it's not one item at a time, it's list at a time. Okay? But those are lists of strings. So I need to convert list of string into list of stack items. So I need some kind of loop, right? To convert the list of strings into list of stack items. So this is what is done in my repository. So here it is. This is list of strings, and again, I'm calling map. And I could use it, but I decided, okay, I will just use list as is to make it explicit. I could, if I remove list here, I will have to use it here. Okay. So this is list in original flow, and I need to create a list which is converted. So I use build list function to do the conversion. This is pre-allocation. So lists are arrays under the hood, so it needs to allocate array ahead of the time, so it doesn't have to copy it each time. So it is pre-allocating list of that links, the same links, right? For the same links. Now I use for loop. It is for each loop in case if I need index. So it's a Kotlin feature. We can do for each loop, and index in this case is provided starting from 0, and it is incremented. So for a list with index, so it's not just original list, it is also providing pairs, list with index. And I'm adding to the new list what I'm about to do, stack items, by calling constructor. Okay. So this is the value in the stack item stored, and this will be count. Size minus index. So I figure it out, it's right. So it is counted to top to, it's counted bottom to top. It's not just order bottom to top. That is done by descending order. I also need to count it bottom to top. So this is two separate tasks, bottom to top count. So this is, I'm doing the data transformation in the repository, and I need to tell how to do it, in what scope, in what context, dispatchers IO. See, with context, dispatchers IO. So it is task related to inputs, outputs. So as you see, it's getting less than immediately obvious, right? Less than immediately obvious. So it does require time to get comfortable, and this is why I'm making examples that is not overcomplicated in terms of it just has one list, one database table, only 2 columns. But the idea is repeated again and again, if you have more complicated issue, but of course with additional features, but idea is repeatable. So this is how a repository is created. Now, how everything is connected. This is interesting, even more interesting. When you need to connect these pieces, you need to do dependency injection, either directly by creating your own code or using HELT. This version is using directly with your own code. Because our course I'm referring to, that I refer to from Google is doing that. So I have to explain it at least once so you understand that code. So in order to do this kind of connections, we have to create application class. So we create application class, how it's called, it doesn't matter, but it must inherit from application. Okay? Application class, it's a globals for your program. Okay? Don't put fancy stuff in it, it just design it to have temporary references that you really have to have. So application class is global. When you create one yourself, this must be mentioned in Android manifest file. If it's not mentioned, your program will crash. So this is absolutely a requirement. So when you create application class, inheriting from application, it must be mentioned in manifest file as name and name of the class. Absolute requirement, otherwise it will be immediate crash. Okay? Next. So it is stored for global. So a global thing, so this is the data what I want to store. It's the references to my repositories essentially. So as this part, and on create is called when this application class is created. So what I do? I do container and I call container constructor. Remember that my database needs reference to context. So it needs to open files on the hard drive, do table initialization. So it needs to have a context. And this is where context is coming from. This. Because application class has parent class up the hill. That is context. So this is where database builder is receiving context right from here. Because I call container with this parameter. Okay? Good so far? Let's see that constructor, data container. A data container is here. Here it is. Data container contains one data field, item repository. This is what way it is, and this is how it's created. Item repository by lazy. What by lazy means? By lazy means execute this code and assign it to the variable when you refer to this first time. So this variable will not be initialized until you refer to it, and it will call this path and assign it to the variable. Okay? So what do I have here? When data container, we call constructor, we have this piece, and when we refer to data container item repository, it will execute this code. What does it happen? We call constructor of repository, right? And constructor of the repository needs item DAO. So we call item database get database. Remember that we can call get database using name of the class, because it's inside of my companion object. So we use name of the class in order to get database. And that object, this is how context is going there. Get database needs context. You remember that it requires context. And item DAO will provide access to the database to my repository. So this is how item repository gets to data container. Okay. Now, there is one extra trick. Somehow this item repository needs to get to view model. Okay. So we need to connect the chain. So let's look from the opposite side when we call view model. Stack screen, view model, here it is. If we don't use HILT, we need to tell view model how to create this object, right? So we provide view model function with the factory. And the factory is a class designed to create objects. Its factory is an object designed to create other objects. So we give view model function the factory, so means of creating view models. Okay? So it will use the factory to create view model if it doesn't exist. Otherwise, it will ignore it and will find view model already existing one. So giving factory to view model function object provides it with ability to create view models when it's necessary. So this is the meaning of giving factory. Use the factory when you need it. Otherwise, just ignore it, pick view model that exists. Okay, so this is factory. So in order to give it to view model, we need to create view model function, we need to create a factory. So where is the factory? Here it is. APP view model provider. It's an object that contains factory. Okay? And we create this factory by calling function from Android, view model factory that receives lambda function as a parameter. Okay? So inside of it, another function, initializer. Inside of it, we call method, we call constructor of view model itself directly. But this constructor, remember, that constructor call needs to have a reference to repository. Because view model constructor needs to have a reference to repository. So we need to pick this repository from the application class. So here's the magic. So in order to call constructor of view model, we need to pick the repository from application class. So we need to have application class, and this is how to pick it. Stack data application, this is type, assignment. This view model provider Android view model factory application keys, copy paste blah blah blah, as stack application. So this is a magic to get application class inside of the factory. And application class contains container. Remember, we created parameter function. We created data field container. Container contains repository. So this is how factory gets repository. Factory of the view model gets repository. So if you have more than view models, you have to repeat it for other view models. And for dependencies besides repositories. It is done manually, and this is what Google does in the course for every example that is using repositories. This kind of approach. Sometimes they put factory not in object view model provider, because this is just call it here, right? It's just defined here. It's not library object. Sometimes they put a factory inside of companion object of view model class itself. In some examples, but idea is the same. They create factory somewhere, and they give it the factory to view model function. In this case, it is, I copied the idea from some other examples. It's my example, but I copied this idea from I think it is from that database for inventory database. They have this kind of thing. They created object for provider to store factories there. And in some example, it's like that. In some other examples, they put this one inside of companion object of view model itself, and they call it from there. So technically, factory can be in different places, so it's not fixed. And this is just a wrapper to find it. So you can do object name dot factory, and this is a factory. This is kind of magic, blah, blah, blah. I don't know. Something happens under the hood. This is a way to get application class, application object. I don't know what it does. Something. Something under the hood to pull out application class. If we use hilt, factory is generated automatically, so we don't need to deal with it. But we need to provide this information elsewhere, so it's not that. Hilt is designed for larger projects, so the complexity of what we see in this version of the code grows drastically when project becomes bigger. But hilt is smoother in this sense. With larger projects, it's just linearly. It's not entangled. A code of this kind tends to get entangled, like harder to follow, if project is large. Okay. Now we have about 5 minutes before end, 6 minutes. And definitely I cannot explain hilt in 5 minutes, but you will see that transition between this and hilt is reasonably smooth. And I will do transition between this version and hilt version in probably 20 minutes in the beginning of the next class. Definitely it requires extra trick of adding libraries, adding specific plugin related to hilt. And after this, with comparing these two, I will use hilt, because it is a more direct way of doing it. As you see, it is still blah, blah, blah to some degree about creating application class, and then on create, then we create view model provider. View model provider, after this we put factory, as this factory is given to view model function. Since it's mostly copy pasting and renaming, it's not that difficult. So sticking to that, it's not a big deal. But it's better to learn how to use recommended way by Google. So at the next lesson, we will switch to that, and we will keep using that. And this is explained because if you open example from the course I'm referring to, that one, it's not mysterious. Right? So inventory database example is using this. And I will not rewrite it in with hilt. I already did it once, and after this I decided, okay, I don't want. Okay, it's long, tedious, and it's probably not designed to go through every line of code anyway. So I stopped rewriting that example. So it's I will create a new one using hilt, but we will do switch and use it. Okay. So it's time to finish. About any questions?